More pH problems. Find the pH given the hydrogen ion concentration. pH is equal to the negative log of the hydrogen ion or the hydronium ion concentration. So let's just plug these numbers in. All right, A will do negative log of 0.0045, 2.34 ... All right, well, this here has two significant figures. Those digits control the numbers to the right of the decimal. You need to have two digits to the right of the decimal. This 2, the numbers on the left of the decimal, are controlled by the exponent. If we write this in scientific notation, that would be times 10 to the negative 3. So that 3 controls that digit up there. So we need to round this properly. It's going to be 2.35 is the pH. Would be an acidic solution. All right, moving on. Let's do the negative log of 8.7 times 10 to the negative 6, and I get 5.06 and so on. This 6 here controls, when you take the log of a number with an exponent like this in scientific notation, the exponent leads to all the digits to the left of the decimal. We can't do anything about that. That's just included in our answer. One of the reasons we use scientific notation is because to express significant figures. And here we're clearly saying there's two significant figures in this number, 8.7 times 10 to the negative 6. So those digits lead to the digits to the right of the decimal. So again, we need two digits to the right of a decimal. So this is going to round properly. If we do it, 5.06 is going to be the pH. Right, this is also going to be an acidic solution. Is this quantity of hydrogen ion concentration, is it more or less than 10 to the negative 7? Well, it's a bigger number than 10 to the negative 7 right here. All right, it's a bigger number, so you would expect it to be an acid, a pH of lower than 7. All right, so C. Let's punch in negative log of 0.0015. All right, so it's going to be 2.82 is the pH, so this is even more acidic. All right, and if you notice, like the pH scale is a logarithmic scale, so this is like, you know, is 5 is roughly like this number 5 is roughly twice as large as 2.8. Does that mean there's roughly twice as much hydrogen ions? 0.0000. 1, 2, 3, 4, 5. All right, here we go. 0.87. Like, come on, this is a magnitude of 1, 2, 3. It's about 1,000 times more, not twice as much. So logarithmic scales are, in this case, powers of 10. This is about 1,000. If I did that right, it's about 1,000 times more concentrated. All right, and I could have just went from, you know, how far away is 2 then, or 3 from 5. So 5, 4, 3, 2. So it's right here. That's 10. That's 100. That's about 1,000 times. That was probably a simpler way to make my point. Sorry. All right, one more to go. Let's go to D. 1.2 times 10 to the negative 3. Negative log of 1.2 times 10 to the negative 3. Just a parenthesis there. It's going to be 2 point and then 2 digits afterwards. It's going to be 9 and 2. All right, there's the pH of the last one. And these are kind of easy to compare, right? So we should have slightly more. This is slightly more acidic, so we should have slightly more H plus concentration in part C than part D.